For the next set of examples, we're going to create a class called a light bulb. So let's go ahead and look at this code and see what it will do for us. We've got our usual headers here. We're going to create a class. We're going to call it light bulb. All of this stuff we're making public here. So the light bulb is going to have 3 member variables. The light bulb class has 3 member variables. We're going to have the watts they use, the lumens, which is basically a measure of their brightness, essentially. And then there's the temperature. There's something basically known as the color temperature. So essentially, the different colors of light bulbs have a different sort of, I guess, heat to them. You know, white bulbs are hotter than yellow bulbs. So anyway, here's a constructor function. It's the default constructor. It doesn't have any arguments in the parentheses, you will notice. And we're going to initialize the light bulbs so that they have 60 watts. They generate 900 lumens, and their temperature is 2700. So this is the class definition right here. The next thing we're going to do is overload the operator for multiplication, which is an asterisk. So the type of object will be a light bulb. That's basically like the return type, just like with a function. We're going to use the keyword operator, and the operator we're overloading is the asterisk, which is normally multiplication. The first thing that it does is it takes in a light bulb, or the first thing in front of the operator is a light bulb, and we're going to name it bulb. And then what goes after it is an integer, and that integer is going to be what we're going to call the increase factor. Inside the function, the definition of the operator, we're going to say we're going to create a light bulb class object. It's going to be called ans for answer, because this is going to be what it returns. It's going to return a different light bulb object. What this will do is we're going to take ans and we're going to set the value of watts used. And what we do is we're going to take from bulb, the light bulb, we're going to take the watts used and multiply it by the increase factor. So basically, when we have a light bulb, whatever the watts are, it's going to multiply it by this number. Likewise, we're going to take the ants for lumens. That's going to be the lumens from the bulb times the increase factor. So like if we're going to times by 2, we're going to double the watts, we're going to double the lumens, but the bulb temperature, we're actually going to leave the same. So you notice the answer temperature is going to equal the bulb temperature. Because usually you can change the wattage and the brightness, but not change like the color temperature of the bulb itself. So in the main program, we're going to create 2 light bulbs. We're going to call them bulb A and bulb B. We're going to say bulb B is equal to bulb A times 2. So bulb A is just going to be initialized with the default, and actually bulb B will be as well. We're going to reassign bulb B so that it is double that. So then here we are outputting. We're going to do from bulb B the watts used, then do a space just so it looks kind of neat and pretty. We're going to do bulb B, we're going to output the lumens, and then a space, and then we're going to do bulb B the temperature. So this should be 120, 1800, And then the temperature will be the same at 2700. So there you go. So we have defined an operator of a bulb times an integer, and it'll create a new light bulb, and it's going to just double or triple whatever number I pick. It's going to multiply some integer value by the watts and the lumens, but not the temperature. So we've essentially discussed all of that. So one thing to be aware of, operators are not automatically commutative, which means we can't just change the order and expect to get the same result. So in our problem, in our example, we did bulb A times 2. If you do 2 times bulb A, that is not actually going to work. And I'll actually do that right here. I'm going to do 2 times bulb A. Now you might think, hey man, 2 times 3 is the same as 3 times 2. What's the big deal? That's how I've been multiplying like my whole life, bro. And you're like, well, the compiler is not going to assume, see, now I got mad at you. The compiler is not going to assume that operations work in both directions. And fun fact, in higher level math, there are plenty of operators that are not automatically commutative. So that's not a good thing to assume in the first place. If you want to be able to do that, you have to basically do this whole process twice. So a lot of this is exactly the same. So this we already had. This is the definition where we overload the operator. It starts with a bulb, and then after that comes an integer. Well, here we're going to do the same thing. Here we're going to start with an integer, and then after that comes a bulb. It's going to do the same thing. And then if you do that, now you can do 2 times bulba, or bulb A, I should say. 2 times bulb A. And now it will actually work. So you might want to do this because people who are using your program might expect that, you know, the order you multiply in doesn't make a big deal. And so you might want to give them the versatility and the option to put the 2 first or put the 2 second. But C++ is not going to just do that automatically. You have to do separate operator overload definitions in order to achieve that.